Welcome to qnawire.
Okay, so this is the force diagram for the hoop. Let's take a look at the moments about point A. Consider counterclockwise moment is positive, therefore clockwise moment is negative. And this will give us such equation here. Eventually, we'll have Fb plus Nb is equal to P. Fb is the friction at point B, Nb is the normal force at point B. And we know Fb can be equal to mu s Nb. Mu s here is the coefficient of the static friction we are looking for to determine. So we have mu s Nb plus Nb is equal to 2P, which means that Nb times 1 plus mu s is equal to 2P. So we have Nb is equal to 2P over 1 plus mu s. So now let's apply force equilibrium for this question, and it's give us the net force along xy direction is equal to 0. So along the x direction, we have Fa plus P minus Nb is equal to 0. So P is equal to Nb minus Fa. Fa here is the friction at point A. So on y direction, we'll have Na plus Fb minus W is equal to 0. So we have W is equal to Na plus Fb. W here is the weight of the hoop. Na here is the normal force at point A. So we know Fa can be equal to mu s Na, Fb can be equal to mu s Nb. And this will give us these two equations here. Since we can use mu s Na substitute for Fa and mu s Nb substitute for Fb. So now let's try to cancel out the Na term. So that's how I do it. So I use equation 1 plus mu s times equation 2. And this will give us P plus mu s W is equal to Nb times 1 plus mu s squared. So if we do some arrangement here, eventually we'll have Nb is equal to P plus mu s W over 1 plus mu s squared. And we know Nb can be also equal to 2P over 1 plus mu s. So now we can set out these two equations equal to each other. And this will give us such equation here. And then we can multiply by each other with the cross here. So this will give us P plus mu s P plus mu s W plus mu s squared times W is equal to 2P plus 2 mu s squared times P. So we actually have such equation here. So now let's assume that if P is equal to W over 2. So now we can use W over 2 substitute for P. Eventually we'll have the coefficient of the static friction is equal to 1/3. So for the another case now, so when the P is not equal to W over 2, we'll have mu s is equal to such equation here. And then if we do some arrangement here, eventually we'll have mu s is equal to P plus W plus minus square root W plus 7P times W minus P over 2 times 2P minus W. As you can tell, W plus 7P is definitely greater than 0 because both W and P are greater than 0. And we also know that W minus P must be greater than 0 since it's under the square root. And this will give us the weight of the hoop is greater than the force P. And we also know that both P and W is greater than 0. And this will give us central ranking here, which is 0 less than P and P is less than W. So when 0 is less than P, less than W, and when P is not equal to W over 2, we'll have mu s is equal to P plus W minus square root W plus 7P times W minus P over 2 times 2P minus W. So you guys may ask me, where's the plus term? Like where's the P plus W plus square root W plus 7P times W minus P? Well, we know the coefficient of the static frictions is always less than 1. And the only expression that can allow mu s is less than 1 is the expression here. Therefore, this is the answer for this question.